Hello, this is Jeff Hamrick at Rhodes College, and I want to spend a few minutes talking about how to execute a paired samples t-test in SPSS. So I've already imported into SPSS a data file that's available on our Moodle page. It has final examination scores for two of Professor Dunwell's sections of Math 111, Applied Calculus, from a couple of semesters ago. In that class, Professor Dunwell has her students take a two-part final. One part of the final is a Mathematica component. The other part is a written component. And students often suppose that they are going to do worse on the Mathematica component than the written component. And so the purpose of working with these data is to test the notion that there is a difference between the Mathematica component scores and the written component scores. Now both of these are given in a percentage of possible points earned out of all available points. And these data are perfectly set up for a paired t-test precisely because there's a special connection between individual members of the two groups. Namely, this row represents some particular student in her class who got a 98% on the Mathematica component of the exam and a 68% on the written component of the exam. So here's how we run a paired samples t-test in SPSS. Click on Analyze and then click on Compare Means and choose Paired Samples t-test. Okay. You need to identify the two variables that form a pair. I think the best way to do this is to avoid using the arrow right here and to just drag these over. So I'll drag Mathematica over to make the first part of the first pair, then I'll drag written over to make the second part of the first pair. I don't have any other pairs that I could possibly look at in this data set, but if I did, I would drag down the appropriate information here and here. The last thing that you can ask for is, as is typical, a confidence level for an associated confidence interval that will be output by SPSS. So let's say we want a 90% confidence interval. If I go on ahead and press continue and then OK, SPSS will generate the output from this procedure. Let's give it a minute to think. It's been turned off. Okay, so we get the same usual output structure that we're used to seeing. Descriptive statistics at the top part, namely the mean Mathematica component score and the mean written component score. We also are given information like the correlation between the two data sets and a p-value associated with a test as to whether or not this correlation is significantly different from zero. But what we're principally interested in is the data in the third box, namely the output from the paired samples test. So we have a mean, and this is the mean difference between the Mathematica and written scores. That is, if you take the differences between people's Mathematica scores and written components, and then you take the average of those, that's this value right here, which is of course just the difference between these two numbers. We have the standard deviation of those differences, the standard error of those differences, a 90% confidence interval on the differences, a test statistic right here, degrees of freedom being one less than the total number of data, and finally a p-value that has been doubled because we're assuming that the alternative hypothesis is two-tailed. Okay, so just to step through one interpretation, this means that we're 90% sure that the true difference in the Mathematica component scores and the written component scores is somewhere between 6.2 and 16.13. In other words, the Mathematica scores are definitely significantly higher. The probability that the Mathematica scores appear to be greater than the written component scores, the probability that that's due to random variation is extremely small. Okay, so this is how you run a paired samples t-test using SPSS.